Hello everyone, welcome back to my YouTube channel. In this particular video, we'll be looking into how we can access a large language model using Groq, which is a fast AI inference. Now, talking about fast AI inference, it refers to high performance AI inference. This solution is provided by the Groq company. It is a hardware and a software company which specializes in accelerating the machine learning workloads. Groq uses LPUs, that is, Language Processing Unit. It is a general purpose compute architecture that is very much ideal for low latency, high performance workloads. It is designed to overcome the bottlenecks in AI inference, for example, the memory bandwidth and the compute density. So I hope this instant introduction of Groq is clear to you all. Now let's see how we can access a large language model through this Groq API. Now, here in this website, groq.com, you need to just visit the dev console. Just click on that and you will be redirected to this particular page. Here you can create an account using Google, GitHub, or email. I am simply logging here with the Google account. So, this is the playground interface of the Groq API. This acts as a console. Here you can play with different language models. Over here, you can see at the top right, we have this drop down. Here are the available models that Groq has, and we can use any one of them. It contains Google's model, LLaMa 3, then the Digital Whisper model, then the different versions of LLaMa, Mixtral, Whisper, and so on. Now let's try to use any one model over here. You can see this. I am selecting this LLaMa 3.170 billion versatile. Let's select this, and now you can simply put your user message over here. Let me write hey and submit it. You can see it gives an instant response from the LLaMa 3 LLM. This platform provides the answer very fast. Now if I ask this what is the capital of India and submit this, you can see we instantly get the capital of India is New Delhi. So I hope how we can use it in a playground is clear to you all. Now we'll try to use the model using the Python code. So for that we'll be requiring the API keys. So let's click on the API keys. On the left you can see at the sidebar you have the API key option. You just have to click it. Once you click it, you can create an API key from here. So if I try to click on this button, create API key, you can just name your API key over here. For now, I'm just naming this as this and submit it. You will be getting your API key over here. Now it displays this API key one single time. So you will have to copy it and store it somewhere so that you can use it afterwards. So I'm simply copying this, click on done, and our API key has got created now. Over here you can see the metadata also created, at what time you have created this, last used, and the usage in 24 hours. So for now we have 0 API calls. Now if you go at the playground and on the right side of the model drop down, you can see the view code button. So you can just click it. Here is the code for you to use. Here they have provided you how we can call our selected model through the chat completion that Groq has defined. So we'll simply copy this particular code and let's come at VS Code. So I'm inside the VS Code. Now let's paste this particular code. Now first we'll have to install the library Groq. So for that we can simply do pip install Groq. So let me do that, pip install Groq, and you can simply execute this. So here you can see we have successfully got it installed. Now we can use this. But before that, we'll also have to define the API key for it. And API key for Groq can be defined as an environment variable. So what we can do is we can simply import OS and we can set the environment variable as the Groq API key. So it will look something like this: os.environ. So os.environ, and in this we'll pass on the name of the key. It will be something like this: Groq underscore API underscore key. And then we can simply pass on the key that we have copied from the website while creating it. So I'll simply paste it here and will execute this particular cell. You can see I have simply defined the Groq API key as the key that we have pasted here. Now we are done with this. Now next here you can see inside the client.chat.completions.create, you can see first we have the model name. Next we have the messages variable, or I would say the parameter. Inside this you can see it is a list. Inside this we'll have to pass on the messages. Messages means the prompt that we have to pass on to create the output. So it will be inside a dictionary. First we have to define the role of the message. For now I'm simply defining the role as the user. So I'll write this, and next you just have to pass on the content of this user role. So I'll define a key named content, and then I'll write the prompt, that is nothing but the user prompt for which I need to get the answer from the LLM. And here we have defined this query: what is the capital of India? So now here we have written this particular messages also, and I would like to remove this stream equals true because I don't want the output in the form of a stream. Now I'll simply remove this for loop, and let's take this print statement here. We will be accessing the completion dot choices. So I'll write completion dot choices of 0, and then I'll remove this. Let's see what we get over here. Cool. Here you can see we are getting something. We are getting the choice object inside which we are getting the content as the answer to our query. The capital of India is New Delhi. And here you can see the rule also is given as assistant because the LLM has provided this answer. So yes, this is how you can get the response from the LLM. Now we'll use another model. Let's see what all models we have. Let's try to access this LLaMa 3.1 70 billion versatile model. Let's copy the name of this particular model, and here inside the code let's paste it. And for this we don't have to change anything. Let's execute this. Cool. Now we are getting the answer from LLaMa 3.1, which is a 70 billion parameter model. We can also try for different queries. For example, if I try to write, tell me a poem on monkey. So it should create a poem. Let's see. Cool. We have got this. In jungle depths where trees preside, a mischievous figure loves to reside. Cool. So it has created some interesting answer. And this answer is from LLaMa 3.1 70 billion parameter. So I hope it's clear to you all how you can access the large language model from Groq API. Now let's go back to the playground. Over here you can see we also have the Whisper model. So there are different versions of Whisper model. Here you can see basically Whisper model, what it does, it takes audio as an input and it will generate transcriptions from it. So basically it converts your audio to text and it's way much accurate. So let's try to use this. Let's select this Whisper model. Let's view the code for it. Okay, so we have to do it like this. Let's copy this. Let me come down here. We already have our API key set. Let me paste the code. Now over here we don't have to define this client again because we already have set the client with the Groq API key. Now what we want here, we will have to pass on the audio file over here. We'll have to pass on the path of the audio file over here. So let's do that. So here I have stored this particular file rec.m4a, and this is an audio file. Let's try to generate the transcriptions from this particular file. Let's execute this. Cool. I'm getting the audio to text over here. Hello everyone, my name is Yash. I love to explore and teach data science. So you can see how pretty accuracy it has. It is very much powerful, and Groq makes it more powerful by making it more and more faster. Hope you will love this particular thing if you try it on your own. Now we are left with images. Let's not miss that. Let's see if we have any large language model which converts images to text. So inside the playground you can see we have the model LLaMa 3.2 11B vision preview. So this vision model will have the capability to read the images, to caption the images, to describe the images. It also has the capability to perform the optical character recognition from the images. It can extract the text from the images. So we can use this particular model LLaMa 3.2 11 billion vision. So let's view the code for it and let's copy this. Now over here what I'll do is I'll paste it, and let's not define the client again because we have already defined it. Now what I'll do is I'll simply remove these parameters from here, because over here we'll only keep the model name and the message parameter. Now first we'll have to define the messages. Before that we'll also have to convert our image to the base 64 encoding. For that I'll be writing a piece of code. Now what we'll do is we'll simply import the base 64. We'll define a function, say encode image. Inside this, we'll pass on the image path. We'll open the image file with open image path. We'll open it in the read binary mode as image underscore file, and we'll return the base 64.b64 encode, and inside this we'll pass on the image file dot will read this. We'll simply decode this particular image file UTF-8 format. So let's execute this particular function, and now that we have defined the function we'll simply check. Let's say if our image underscore path is nothing but, so let's pass on the path dog.jfif. So this is the path to my image file, and what I'll do is I'll simply pass this particular image path into the function encode image. Let's see what it returns. Let's try to print the output. Cool. Over here you can see it has converted it into the base 64 format. Now what we'll do is we'll use this base 64 format and we'll pass on it in the messages over here. Now let's define it. So as usual, first we'll define a dictionary. Inside this we'll define the role. Obviously the role would be user. Next we'll have to define the content. Now over here our content would be more than one. Why? Because we are going to pass on the text as well as the images. So here what we'll do is we'll define a list. Inside this we'll define a dictionary. First we'll pass on the text, that is nothing but the user prompt, which will tell what has to be particularly done with the image that we are going to pass on. So type equals text, and then we'll simply write the text that we want to include. The provided image, what is dog doing? Now that we have defined our text, or I would say the user prompt that we want to pass on, will now pass the image. Inside this we'll define the type as image underscore URL, and then what we'll do is we'll simply define the image URL in the base 64 format. So let's define it in a dictionary. We'll write URL. Here we have to pass it on the base 64 format in this way. So we'll write data colon image slash the format GFIF semicolon base 64. Why? Because we have converted our image file into base 64 format, and then a comma. Then we'll simply pass on the base 64 format over here. So Since we haven't stored it in any variable, first we'll store it. So let me write B64 over here. Let me define the name as B64 and let's execute this. Cool. Now we'll simply pass on this B64 over here. This is how we have to pass on the image. Now let's try to execute this. So now we are done with our code. Let's try to execute this. What we have done, we have simply passed on the base64 format of the image path. And let me show you the image first. This is the image. Over here you can see the dog is playing with the ball with the owner holding the dog's rope. So this is what is the description of the image that we can see by our own understanding. Now let's try to see whether the LLaMa 3.2 model is going to get the same answer or not. That we have seen the image, what we have done, we have passed on the image URL and we have simply asked the question to the LLaMa 3.2 model that in the provided image, what is dog doing? So let's try to execute this and let's see whether the LLaMa 3.2 model gives the correct answer. So let's execute this. Cool. So here you can see we have gotten some output. The dog in the image appears to be playing or interacting with the soccer ball. In the foreground, a happy dog with its tongue hanging with the soccer ball. So over here you can see we have gotten the answer to our query. Additionally, it has provided some other features inside the image, which is not that useful for us because our query was only regarding what is the dog doing. So we can simply write some instructions which will restrict it to the provided question only. Don't provide any other explanations. So if I execute this, I hope it will give the answer. The dog is playing with the ball. So you must have got an understanding of how LLaMa 3.2 is powerful and how we can get the response from the Groq API. The response seems to be very fast and very accurate. So I hope it's clear to you all how we can use large language model present on the Groq API easily. We have seen how we can use a text model as well as we have seen how we can use an audio transcription creator model which converts the audio into text. We also have seen an image to text model which is a popular one, LLaMa 3.2, and I hope everything is clear to you all. If you guys have any single doubt, then you can straight away put it in the comment section. I'll be happy to solve it. For more such videos, do like, share, and subscribe to my channel. Also hit the bell icon and don't forget to follow me on Instagram. Please join me on Telegram. Thanks for watching. Have a good day ahead.